All right, folks. So I learned a lesson. This is my second attempt on problem 18. And the lesson is sometimes it's okay to just use the calculator. Okay. So what do? We have our line here. And if you look at that linear equation, you can just read off the direction vector of the line as 2 steps in the x, 5 steps in the y, p steps in the z direction. Same idea that the normal vector to the plane is just 5 steps in the x, p steps in the y, and p steps in the z. And now normally we use the idea that the cosine of theta is equal to a dot b over magnitude a times the magnitude of b. But that tells us the angle between the two vectors that we use. But we actually were using the normal vector to the plane. And so the sine of the theta is the one that tells us the angle between the plane and the line. And so what we do is set up sine of theta equals 2 5p dot 5p p over magnitude. So 4 plus 25 plus p squared, 25 plus p squared plus p squared. And that tells me that sine of theta is equal to 10 plus 5p plus p squared over 29 plus p squared times 25 plus 2p squared. And in my first attempt at this video, I was just hacking away and taking the derivative and trying to set the derivative equal to 0 of that really gross looking trig expression there. And instead, you can just type in the value into the calculator there. Okay, so the uh, angle of theta will be the maximum when the sine of theta is at a maximum. Is that actually even true? Oh, textbook. I don't know about that. What I'm going to do is actually get a true function here. So I'm going to do arcsine. And so I'm going to still use the calculator. I don't 100% trust what the textbook's answer key is saying, but I'm going to do the arcsine of all of that stuff and then just look at it on a graphing calculator. So let's go over to Desmos. And I'm going to pause and I'll see you over on that side. Well, here's Desmos. So let's see how this works. You can type this in, on just a regular calculator as well. But Desmos is nice on the computer. So we're going to do the arc sine of, does it not know arc sine? Yeah, requires an argument. I know that. So arc sine of 10 plus 5x plus x squared. All that is going to be divided by, we said, square root of 29 plus x squared times square root of 25 plus 2x squared. And we are looking for the maximum value of that. And that occurs right here, which is the same value that the textbook gave. So that's our maximum p value. So we can say that the p value is equal to, it just went away, the p value is equal to 6.797. And then that means that if we take that value and substitute it into the arcsine, it'll tell us the value here of the angle, which is 1.286. And that is if you measure it in terms of radians. So the theta max is, come on, work with me, 1.286 radians. So lesson learned here that if you feel like you're hacking away at a really gross quotient rule, chain rule, optimization problem, perhaps you were just supposed to graph it and look at the highest value there. Okay, so that was that.